This is the Nepio SDK weekly meetings for March 12th, 2024. For today's agenda, Dan reached out, and then because he makes some good progress, so I'll give him the stage for now. Go ahead, Dan or Dijon.
Can you hear me?
Yeah. Yep, I can hear.
Yeah, so it's been dragging along because I didn't have so much time to look into this, but we were talking about the Nepio CLI and how we can create some sort of a CLI to work within the Nepio SDK. And I said, I'll take a look on what could be done there in context of, can we generate some code with it? And we were talking about perhaps potentially need of generating the operator out of it and other things. So I looked into that, and what I basically found out is like there are three approaches I think that we can take there. One would be to wrap the operator SDK, which I think would not be the best way to do it because the operator SDK already wraps QBuilder. The other one would be to wrap the QBuilder, and the third one for generating anything operator related would be just to use the QBuilder, in a sense that QBuilder allows you to extend it with plugins. So we talked a little bit beforehand, and I'll share my screen briefly. So I didn't produce anything spectacular around it. It's just something that I've been playing with as an idea. What I did is I took the QBuilder, and I can generate an operator that will reconcile the NF deployment, and alongside with it, it also generates the CR that would be some sort of a vendor-specific CR, so that those two could be plugged in together. I didn't generate a lot of specific boilerplate code or anything specific inside it because I wasn't sure how all of this would plug in into the story down the road with Kform or anything else that we might go with. It's just focusing solely on what we can do in terms of a CLI to generate some code out of it. So it's a very simple thing. So if I create a test folder, and then if I invoke the Nepio CLI, oops. A second to find the command. See my screen? I didn't even ask. I had problems sharing the screen before.
Yeah, I can, at least I can see it.
Okay. There we go. If I run the command, it's basically I'm asking to generate an operator that will do reconciliation on NF deployment and provide the CR for the domain nepioericsson.com. It'll name the operator whatever, and it will specify the version and the group, and it basically mimics of what the operator should do once there is a reconciliation of NF deployment and the provider ID is matching something that would be, for example, of Ericsson type. So it just scaffolds the entire project for you, same as QBuilder would do. It creates the custom CR from the scaffold for whatever would be the Ericsson stuff or vendor-specific stuff. That's just a general CR that gets created, and then alongside with that, it also creates the one that's watching the NF deployment and pulls down the NF deployment CR in it. And in the internal part of it, in the controller, it just stubs the very basic controller, which is watching the NF deployment in there. So this is all the boilerplate that I did. Like I said, I wasn't sure how far should we go with it, but that's one of the alternatives, how we can generate code out of it. The other one would be potentially better for more complex cases, and that would be to use the concept of the plugins that the QBuilder has. So the QBuilder itself they allow you to build a plugin so that then when you're executing the queue builder, instead of executing the default plugins for the Golang or any other language or anything else that they provide, you can actually tell it to execute your own plugin. And then your own plugin is the one that's generating the boilerplate code from the templates that you provide. So in this case, we could generate something like this. I don't have this fully working, so it's a work in progress. I still haven't made it to work with QBuilder. But basically, we provide inside of the scaffolds any kind of a boilerplate that we want. And then when we execute the queue builder, it's using those templates from the scaffold and generates a project, same as the queue builder normally would do, but only with our own templates and with our own files that we wanted and we needed in there. So that kind of kickstarts off a nice code generation. There's nothing in it in right now because, like I said, we should probably agree on some level of where we would add this and what should be auto-generated inside, and even more so, like Steven pointed out earlier, how does it plug in into the other things? That's basically where I'm at the moment. So I think this is a better approach, actually, if we are going down the road of generating something rather than wrapping the operator SDK or wrapping the queue builder commands itself. We can just implement a plugin for the queue builder, which will generate all of the stuff that we need and scaffold the project. So I don't know, any thoughts, comments?
So in this case, if we scaffold our own stuff, then this builds a operator image that are basically fully generated by our stuff, whatever we write inside in terms of boilerplate.
It builds exactly the same project as you would get with operator SDK in it, create API with a controller or queue builder, basically doing the same thing. So you get a makefile, Docker image, all of the CRs are defined, or all of the controllers are present in there. The makefile, customize, and all of that will build a project, create a Docker image out of it, create a Kubernetes manifest out of it, a whole project that you can do, make, install, and it will make build, make deploy, and it goes onto the Kubernetes cluster as a deployed operator.
Right. So all those make options are available.
Yeah. Only with this, whatever we provide in the scaffold, that's what it generates.
That would be the generated skeleton.
Yeah.
I think the question would be how I mean, so you don't have to use Kform, but then in case we're using Kform, how would that get plugged in? I guess that's the question for them.
So I think in the case of Kform, you don't need this. There is two things.
Okay.
So first is, I think so the API that we have, right, is defined, right? So if you look, for our NFs, we use NF deployment as the API, so we don't have to generate the API. But the way it works with Kform is you basically think of it as a config map, right? So what we need somehow is a project where you basically say, and I'm using config map, we can use other systems, right? So you basically have to say, here is a config snippet that so let me take a step back. So we would have a controller runtime image that Nefio owns. Let's call it Nefio controller or Nefio controller runtime. We kind of built, okay? What that image does, it uses controller runtime as is, right? With a few things that we add on the basis of controller runtime. For example, the thing that you have to do is say, when you start up this operator, let's say there is a config map that you mount into it. Right? Let's take the simple thing. You mount that config map into it, and then what the controller does, it reads that config map, executes the DAG, and makes the DAG available towards the fore, right? So towards your NF deployment watch, right? And you basically say, if provider is Ericsson, right? Run this DAG, right? So in other words, what we would do is it's very similar to what we showed with what Fiacra showed with Helm, right? In Helm, what happened is you generate the code, which actually points to a binary that Red Hat maintains, right? And then you have your values file that is mounted into it. And so you basically spin the two up, and then it basically executes the thing. So it's going to be similar to that with Kform. So in other words, we would have a binary, let's call it Nephew operator, right? And when you start it up, the pod will have a mounted config map to make it simple. And it will read it in, and then when it starts up, read in the config map and put it to the controller runtime hook for the watch of NF deployment. And the first thing it probably does is says, if provider is Ericsson, right? Then I execute. If I get the NF deployment with a provider of Nokia, it will say, not interested. Go somewhere else, and it doesn't do anything.
Okay.
So in other words, scaffolding a project is not necessarily needed in that case. Because what you do is what might be useful is scaffolding a pod deployment. So basically a manifest on which that logic resides. So in other words, Ericsson has its own config map, and Nokia will have its own config map, and so on. So what could be useful is basically build a system where you basically point to that binary and with that particular config map, and then and that's it. Yeah. Does it make sense?
So I don't entirely understand. I guess we're talking about, there's a spectrum of solutions we can make from code generation, right? Which is what we're looking at here. And, the operator SDK, if we rely on the operator SDK, we rely on code generation, right? Code generation is kind of the bread and butter of working with the Go client for Kubernetes, right? There's a lot of code generation there. On the extreme other side of the spectrum, we can have a pre-built runtime that does everything dynamically, right? So it's a configurable component, right? This is where people come up and say, oh, is this a GVNFM, right? No, but it is the idea that we have a component that's pre-compiled, pre-running, and then you can configure it to delegate to other things, right? Your own pod or some other script, right? I showed something called kplug that can let you run plugins, but there's a lot of ways that you can make these connections dynamically, right? And then in between, we could do something that's, maybe without code generation, you still have to write your own code in Go, but something that's, I don't know, simpler to use than something with code generation. So I don't know quite what we decide, right? I don't think we know, right? I think there are pros and cons to all these approaches, and it's kind of like, how good is the experience at the end for developers? I think probably the easiest experience is if it's pre-built and you just have to attach your code. But then there are cons to that, right? Because you're working entirely with the opinion of that controller, whatever it is. If we do it right, then that's a good way to work, right? And of course, users will always have the option of avoiding our SDK and writing their own. So I feel like we're on the cusp of trying to decide that. So I just want to lay that out, what our options are here. And we've done a lot of experiments with the former, right? We've mostly used the operator SDK. We use KOPF in Python, which doesn't need code generation, but it's also, write your own code. We've had a few experiments on doing it in runtime, right? I showed kplug, but it's pretty basic, right? Maybe basic is all we need, right? So I guess we need to decide which way we're going. It could be always, both ways, three ways.
No, I mean, I think we obviously need to allow people to write their own operators with like absolutely their own. Well, it's still opinionated, I mean, by KubeBuilder anyway. But then at least maximum flexibility. The only thing we are restricting them is, if NF vendors writing about the NF deployment related things, then you're watching NF deployment. the idea that both you and Vim actually suggested is let's take it a next step and avoid even writing any code at all. And that would, at the very minimum, require some sort of, I've been calling it proxy operator, proxy operators that are running. It would execute something generated during compile time, whatever form it is, and then be able to do it. And your kplug, for example, would have been a gRPC backend that someone still have to implement, and then load it into the operator images, and then in Vim's case, there are a bunch of config map generated, I guess, during compile time, or at least the config map resources generated. And then
not during compile time, it's during when you start it up, it will generate it, or when you change.
So the config maps, I'm guessing the config map then get when you load the operator image, you bundle the config map inside the operator image, not image, the operator package, and then the config map get,
through the pod mounting, right? So when you mount the pod, you get it.
Okay, yeah, it's still a real object in Kubernetes API server, and then the proxy would then read that config map, and then somehow we have a metadata fields to know which config map. I guess it could be just the name of the config map that maps directly into a provider field, and then it looks for that config map. If it's mounted, it's a go. If not, then it's not there. So I see, because the config map is mounted during. Also, the config map is mounted during the time of writing the deployment of the operator. So while we're generating that package, we would have the deployment resource inside a package where the config map is already mounted as part of the generation. So when Dan reached out and I look at this, because I've been trying to write the proxy, and then I was just wondering if we have a common way where the proxy would be by itself would be scaffold generated by the tools, because the idea would be, do we have a vision of having a single operators able to invoke different providers?
Yes, yeah. I mean, yeah. In Kform, the way it works, Stephen, is basically every vendor will have its own, let's say, config map, right, with its own logic of things that he needs, right? So, so in other words, that's why I said is that in the case of Kform, what you do is you basically say, I'm this provider, I'm this config map, and I act based on that provider, right? So I'm, let's say, an Ericsson thing, and I'm a Nokia thing, or I'm a Samsung thing, or I'm so each of them have their own way that they do stuff, right? And then they act upon the configuration you provide.
But then the mounting of it, can we dynamically mount?
Yeah. So if you create a pod, right? So if you create a deployment and you say there's a volume and you say volume is config map, you automatically, Kubernetes does it for you. You don't even have to write any code.
So that basically means wait. So basically means that
Kubernetes won't restart a pod if you change the config map, but there are ways around that as well.
Yeah, well, the mount point for sure, you have to restart the pod. There's almost no way to get around it. So I mean,
yeah. For example, one of the things that you can do is you can put a GitHub. You could basically point to a repo where that map is thing. So we can do more advanced stuff, but we can start with the basics. That if there is a change, you basically download it automatically and stuff. That is more dynamic stuff that we can do, right?
Okay. Yeah. So there is a visions where we using this, we'll basically use one operator is able to invoke different DAGs based on providers.
Yeah. Or we can even go to other approaches, right, where you say it watches a specific CR with a name that you provide through an environment variable. I mean, there's a gazillion ways that you can get this to work. But I think we have to get the basics to run, right, before. Yeah.
Okay. So here the question would be, I think we talked about that last couple of weeks, that there's certain hook points that we want to do based on on executing a DAG. So they at least like create and modified. That's one, and then delete is another one.
Yeah. You can hook to certain events if you want, but I don't know whether anyone looked at it in the meantime. But I was just trying to. My comment was before. It's always like Stephen asked how it would work for Kform. I said in Kform you basically build that binary once, right?
Mm-hmm. So in Kform, the proxy, the controller runtime piece is it's already done. It doesn't need to be generated, basically.
Yeah.
And then in that case, we probably still point to that operator deployment object, so that they know which one to deploy it. But in addition to that, it's just generating config map objects, and that get bundled inside the operator package. Okay. And then as you demonstrate before, that itself has their own set of CLI already. So you have a command line tools that were hooked up.
Yeah, it's basic, but the command line tool is very simple, right? So it basically run, and you can change the input.
Oh, okay. Yeah. Oh, it runs
That's all
directly. That's right. So it's but then you can change the output by pointing it to saying that you just instead of running, you can generate a config map, basically.
Yeah, I mean, what you could do, I mean, for people to write, because the config map will be for every vendor is different, right? Right.
Mm-hmm. Yeah.
That someone has to write, of course.
No, you have to write the logics to map NF deployment plus vendor extension into whatever that values that YAML is. So that never goes away. Someone has to do that mapping.
Yeah.
And that in this particular Kform tools, the output is a config map. And
yes.
And that config map is interesting. Okay. But anyway, so the vision would be the config map itself would be bundled inside the NF package rather than the operator package in that case, because that already points to an actual network function deployment of network functions rather than changes the operator.
Yeah.
Okay.
So is the idea, Wim, then that you would define a custom resource or a config map or something that goes into the NF deployment? This proxy operator, Stephen, that you're talking of writing would then pass that to Kform. Kform would have some kind of logic associated, some kind of a transformation. I don't know what the term I'm looking for is.
Yeah, so the DAG execution. So the question is going down to the DAG executions. Is the execution of the DAG a logic that is provided by Kform?
Yes, and there is a proxy in Kform itself, right? So there is a resource which is a proxy, right? So there is a provider, right?
Mm-hmm.
So there is a provider resource which can basically reach out to the Kubernetes API server, right? So you basically can say, give me, let's say in NF, let's maybe go to the flow, right? So maybe let's take a simple case. NF deployment has a config ref, right? Or a parameter ref that basically says, here is a config that I want for as input to generate values.yaml, right? So that's NF deployment comes, and it has a config ref to a certain group version kind, namespace name, right? That that we identify, right? So in its simplest form, what the DAG should do, right, is, okay, you get the NF deployment, you read the NF deployment, you see I have a config ref, I need to fetch it, right? So that's the first thing that it needs to do. So one step in the DAG is fetch that config. So it basically, you say group person kind, namespace name. So it calls the provider that is, so I call it a Kubernetes provider. It basically fetches that config that you reference, and it now is part of the DAG. So one of the steps in the DAG is fetch that config, right? And that is dynamic based on the input that NF deployment gets, right? And so now you get that data. So from the moment it's fetched, you can now use the content of that data to generate values.yaml. You basically say, okay, if I have this config map, okay, you need to look at this parameter, and based on that, I set this value, and so on and so forth. And then it has a step that does that. And then you basically say, okay, I'm done, values.yaml config map is ready, apply to the cluster, right? So that's another step into the DAG. So in other words, there is a kind of the way Kform implements, and you can build a proxy to anything, so it doesn't have to be Kubernetes, but for that you will have to build a provider, right? So Kform has a way to dynamically plug in providers, so you can basically install a provider dynamically if you want, but you need to get it from somewhere. But if you take pure Kubernetes, let's take it simple, there's only one provider for everything in Kubernetes, because you basically fetch based on group person kind namespace name, and you fetch the data. Or you can even set the data. You can even create an object as well. So you can do all this type of stuff. And that's implemented through a proxy, if you will, so through the gRPC. So there is a thing that does that.
So basically, our Nephew controller runtime would take the config map off of the maps to a particular provider, our provider, meaning that Ericsson versus Nokia, and then from there it would that tells me which config map we're going to execute. So we'll somehow grab that, and then after that we basically just invoke a proxy. So we'll basically use gRPC to call.
But you don't see that, you don't have to do anything for that. Kform does it for you, right? So when it executes the DAG, as part of the execution, if you say fetch that config snippet, it internally does the proxy stuff. So one step into the DAG is basically saying, okay, run this provider. It will run the Kubernetes provider and basically fetches the data. So you don't have to do anything for it. Kform execution, so the Kform DAG executor does it for you. So you don't have to write code. The only thing that you have to write is what you have to write is as part of the config map, you have to write a resource that fetches that data based on the dynamic content that you get from NF deployment, right? That you have to write. The way you have to write it is you get NF deployment.
You have to be able to parse NF deployment and all the config refs that are linked to. So this is basically part of the proxy.
For each of the config refs, you have to fetch the data, right? So you basically have a for loop which loops over the config map, like I showed, right? And then you just fetch that data, and now you have that available. And the way it fetches the data is through this this provider, which is a proxy.
Okay.
But you don't have to write code.
And at that point,
all of that is part of Kform, right? Kform does that for you.
Kform does. So once we give them the set of objects, I guess once we get the config maps and then feed it to Kform does the execution of the DAG for us.
Correct. Yeah.
The idea would be we still need to parse the NF deployment ourselves on the controller runtime or / proxy operator, and then so that.
Oh, but that's Kform does, Stephen, right? So when you do NF deployments, but so these will be very generic things, right? So So fetch config refs will be a generic Nephew thing, but it's a step that probably will always have to happen because that's the way our
yes and no,
API
right?
is
So the config refs, once you unfold the config refs, is a object, right? That's an object embedded inside, right?
Yes, but yeah, correct. So, but so
at least when I parsed it, I have to parse that
Yes.
and parse the UPF deployment back then. So
yeah,
I'm
but
guessing
Kform
that
Kform has the
change.
logic to do that, right? So you don't
Okay.
have to write any code for it. So you don't. It's all there for you.
I presume Kform is a DSL then, that allows you to specify how you transform what's in that
Correct.
object into what
Yes.
goes into the values.yaml.
Correct. Yeah, indeed. That's what it does. Yeah, through
So
the
then-
expressions, right?
So then what you're talking about is an operator which runs Kform, reads in the NF deployment, extracts out the config ref objects, identifies which DSL to execute based on the provider type, picks the Ericsson DSL or the Nokia DSL or whatever, and then that DSL is executed against that, or is used
I would
to
say it's not a
transform.
Nokia DS. I would not say it's a Nokia DSL. It's because the
No,
DSL
it's the wrong
is
term.
Kform, if you will. Yeah,
the DSL is Kform. The instance or the DSL script
Correct,
or whatever.
Yeah,
There'd be a
the
Nokia
specific
DSL
Ericsson.
script or...
Yeah, the specific Ericsson, let's say, logic, if you will, right?
And therefore, instead of writing code in Golang, you're basically writing transformation algorithms in the Kform DSL.
Correct. Yeah.
I think I can see a picture of that in my head, but maybe it needs to be drawn. And
I can draw a picture if you want.
Pictures are usually really good.
Yeah, worth 1,000 words.
That was that was.
Maybe more.
Depends on the DSL.
I'm anyhow writing the documentation as we go. I'm busy writing the docs for Kform, so I'll add a picture into it.
So I'll mention that there's a long list, I think, of projects that try to do similar things as well. Like not similar to Kform specifically, but the idea of providing some delegate between the operator and your reconciliation code, right? Stephen calls it a proxy. Yeah, I think it kind of works like a proxy, but it's not a direct proxy. It's right. It does have its own semantic logic, and then it delegates to a list of operations, right, in the kind of reconciliation workflow. We can look at those for inspiration. We can also use them just as is. People have really tried to crack this, right? We're not the first people who find writing operators to be a lot of work, right? So the idea of having some sort of opinionated runtime in between, by the way, including the controller runtime, right? That's a project we use a lot. Operator SDK uses it. It also has it's a layer that adds a lot of opinions. It's not a standalone layer. It's as a library.
Yeah.
Personally, I can say when I write operators in Go, I write them from scratch. I don't use the controller runtime. I can get into the pros and cons. Like I usually prefer to understand what I'm doing step by step and not add another layer to what's already a lot of layers, right, in Kubernetes. So we can look at those, right, and see if there's a solution that we can just use. I have a list, if anybody wants to go down it. I have not looked at them very carefully, right? So, until now we've been really focused, I think, on the operator SDK, but it's not the only solution, right? There are other ones we can try. And as people know, I'm also in favor of looking at solutions that are multilingual, right? That can support Python and not just Go code. But I think all of these do, right? Once you do that decoupling between the proxy, right, and your code, then there's no reason that you have to demand Go for that code, right? It could be written in anything. And I think that would be the real superpower, right? I think one of the big obstacles here, whether you're doing code generation or anything else, is that you would have to write it in Go. There are a lot of aspects of working with KRM that are just difficult in Go, right? The idea that you have to have, it's a strictly typed language, right? That you need to have structs for everything. And if you're not using structs, then it's kind of awkward to work with generic data in Go. I do have a library that could help with it. I'll present it at some point, but it's still not as pleasant as doing the same thing in Python. So so I don't know. I think I feel like we've progressed in some of our POCs here, but we're still not deciding on some of the basic approach that we want to take. Maybe we need more research. Maybe that's we need more data to make a proper comparison. Here's a suggestion. Maybe we can start with some sort of a spreadsheet that does this comparison and have various columns of the criteria that we're looking for. You know, what will it give potential consumers of this Nephio SDK? And see kind of what the pros and cons of each approach are, and that can help us narrow down a decision, right? Stephen, what do you think? Yeah. Good.
Oh, someone, Kieran or someone?
Yeah, no, I was going to say, I think I agree with you, Charles, but I also think maybe we do need a couple of
yeah, I think we need to do POCs
parallel.
for sure. We need to do an end-to-end POC of some sort. We need to do something. Just to show.
Let's accumulate the results of these POCs somehow, because we've done a few, and we're planning.
Well, we haven't actually done a real end-to-end one. So
okay,
so
yeah, that's awesome.
Yeah. So
I would say two POCs were operator SDK, right?
Yeah, then CLI is like the first step of this is the starting point. So we finally can build upon this and say that let's see, you know, if we use Kform versus not using Kform, it bundles a package that we ended up with. So that's one step, and then what is the content of the package? Whether or not it actually invokes the proxy that actually uses the Kform versus some other stuff, even is another things that we can. There's possibilities that we can go. Go ahead, Kieran.
Oh, I'm not on mute. What was I going to say? Yeah, I thought we had like 3 levels of possible ambition or 3 levels of potential POC. So we could run, one of which is we just have a kind of a Nephio opinionated CLI where you can generate an operator for your particular workload. The second one is your kind of proxy view where you have kind of got a generic operator which monitors the NF deployment and then uses a kind of a the gRPC mechanism or something similar to pass it on to some other business logic that is running, that's provided by the operator. And then the third level, which is the highest level of aspiration, is where you go for a domain specific language for defining transformation from the config ref object into the values.yaml, which means you don't need to do any coding. And those I thought were the 3 specific possible options that we have. And maybe we support all of them. Maybe we try all of them, or we support one of them. To my mind, the DSL sounds compelling if it works, and we can get it to be flexible enough for all of the use cases. But it also sounds quite ambitious. So
obviously, as we immediately pointed out, if we're generating an operator, then that's obviously by nature is a little bit in conflict with having our own proxy operator. Unless you want to also generate as a proxy operator, if we see a use case for that, but that's like, that doesn't seem like a use case. At one point, I thought that would be a use case if we have to parse our own type out of the config refs, but then as Wim said, they're all just GVKs, and the cell would be able to transform them without really understanding the structure. Well, other than the fact that you can look at the CLT and the structure. Well, thanks, Dan. Really.
Thanks, guys.
Definitely is a start. I mean, we need a CLI. We do need that one way where we generate, where vendors have the freedoms to write their own operators.
I think we need some sort of a diagram or at least some sort of a writing of what are these possible end-to-end scenarios and how they could be done, so that we can explore them and at least try some of them. Like so far, it's just talking back and forth.
Yes,
I would love to see like how the big picture looks like.
Yeah.
Without all of this plugging the Kform, how does it look like? How does it work?
Yeah.
And then if that's in front of me, we could even talk about let's try and POC some of it, and let's make an end-to-end POC, or try a second level ambition or first level ambition. But I think we need to have them documented somewhere so that we it's easier to discuss these things if there is a document in front of you describing what we're discussing. Otherwise, we're kind of floating away in many different directions. That's at least my view.
Yeah.
I have to drop, guys. Thanks.
Thanks. But at the very minimum, at least we have a CLI wrapper. But for sure, we still need the side of generating CLDs and things. So I don't think that goes away. We still need to generate from that, if someone wants to do that and write an operator. And an operator is by default will be watching NF deployment. I think that's value by itself. And as I said,
we never said you can't, right? You can do it as we did it with the way we onboarded Free5DC. We wrote an operator in Go.
Yeah.
The way we onboarded OAI, we wrote an operator in Python using KOPF. I mean,
so what the point is, Nephew SDK as a single tool should have that option anyway.
I guess so. You're saying that option. So both of those, right? Using scaffolding for KOPF and scaffolding for operator SDK controller runtime based Go.
Yeah. So the big well, not discovery, I guess, but the big takeaway from what Dan has was you can write your own scaffolding, which scaffolds for the Python one, which would be fine, perfectly okay. But then beyond that, we have at least a CLI wrapper, so we can extend the CLI wrappers to pull into the other functionalities. Yeah, I think obviously I'm still in favor of doing a end-to-end POC for sure, leading up to definitely before the WANI Summit, and how elaborate do we want that to be depends on what the other pieces are actually available at the time of integrations. That isn't that far away, I guess, end of April, right? So we'll like to see that a couple of weeks before that we get some end-to-end, going from CLI to generating packages and load those packages, both as an operator package and all the other dependencies like Flux that would be in the first package, and then having the second package where you do a deployment, which, if Vim stuff is ready, then it could be Kform. The config maps to Kform inside. The Kform would have to be bundled inside the operator package too, in that case. And so that's one of the goals. And then as we go, and there may be other suggestions. But then it is a POC, so we do want to prove to ourselves that this end-to-end workflow works. This is the user experience, and given that we have 3 different vendors represented in this meeting by itself, we are targeting vendor communities more than anyone else, and we would like to see if that fits your needs as vendors, as other vendors. So anyway, so continue on. So based on, I'll continue using that CLI, but even if it's not scaffolding for anything, and the proxy would still be in place. The idea that the proxy would be talking directly into generating a config map for Flux, I think that I still need to do that actually. And then once Vim stuff is ready, then we have to see how we integrate this. This may or may not happen before the WANI Summit. We'll see how that goes. Okay.
Maybe I'll try to put something together. The problem is in the next 2 weeks I will be non-stop traveling, so it will be a bit hard for me.
Yeah. Did you get like Nokia? Did you get Nokia approval for open sourcing, or is it still ongoing?
It's ongoing, but I think it will happen. So that's not the problem. Yeah, so there is 2 people that are out that need to get approvals, but I don't think it's a problem doing that.
Yeah, I mean, so the plan doesn't change. In the meantime, I'll just write a proxy that does enough to get Flux going. So at least we know that flow, and then hook that up with whatever the CLI would look like in terms of generating. So at the very least, the CLI should have an option to generate packages, and then we'll go from that first. And then once Kform's in place, it should make life easier. And then we'll probably even extend that CLI so that people can just give like a map as an input. Okay.
But maybe I'll have to do the first initiative, but it's going to take a bit of time for myself to do it. My
okay.
goal is by this week
Mm-hmm.
to have the docs of Kform. So I'm focused this week on getting the docs out because people should be able to consume it.
Yeah,
that's what I'm doing right now.
Because in the beginning, when I was filing all those issues, the issue of not using code to generate the business logic is is a separate issues. So we have that. It's a great to have, and then we can eliminate a lot of unnecessary code logic off of. At the end, in an R3, we have an implementation as a reference that generates the full set of 35GC operators that will be used officially moving forward and eliminate the old ones. That's our R3 goal. So hopefully the Kform will be part of that, and then we'll see how it goes. Okay, that would be if no one objected that would be the execution plan. And then from that we'll see, other options. I'm sure Tal has a long list of suggestions. But then we get
suggestions, things to look at. I don't necessarily.
So that's why I iterate once, get the end-to-end flow, understanding what the problem is further, and then we kind of have a grasp of what the problem is, but then we will understand it further once we do a full end-to-end integrations, and then after that we'll optimize as we go, or improve, enhance, Kaizen if you're in the Japanese side. So okay, cool. Anything else from anyone? Okay.
Good discussion. Thanks.
Thank you. Give you back 8 minutes.
Yay.
Thanks.
Thanks.